I would like to introduce our last speaker in this session, Mr. Paul Fancher, and he's going to be talking about improving safe transportation for older adults in a socially mobile environment.
After yesterday's session, the first thing I was going to say, and will say, is that my primary care physician is at the geriatric center that you heard about. And then the keynote speaker today gave me great concern about what Google's doing if they're going to attack the University of Michigan. And so, what?
You just need to worry about this button only if you want to move through it.
Okay.
So see what is there, but you have.
Yeah, first, so I'm sort of explaining what I'm doing on this project in some ways, or who I am at least. And I would say I'm a computer information and control engineer. So my world is a little different, and I'm going to be talking about design, which you're all talking about. You got a real thing already, and then you can evaluate it. You can test it and use statistical methods to see what it shows you, which is very important and what I would like to collaborate with, but I'm not very good at. Rachel, we call her, the visiting scholar, is from Brazil. She helps design highways in Brazil and teaches it in Brazil. She's a professor there. She did part of her doctoral work here trying to get big trucks around corners in Brazil and how to design roads. Sergio is another visiting scholar, which means these people have quite a bit of opportunity to decide what they work on that fits back into what they're doing in Brazil. So he's also from Brazil, but in it's a big country, in an entirely different place, in a different university. And he's an expert in economics. So the presentation covers these three areas, you might say, by three different people, but we formed a team, a group to begin with. And so our methodology, which I hear explained here, is about what we were up to. We're living in the world of abstraction in what we're doing. We don't have a real thing. We're trying to design a real thing. So, and I've had a lot of experience with the human factors people at UMTRI, where essentially some of them would tell me, well, give us one and we'll evaluate it for you. Well, that's a different side of the picture, and I'll get to a view graph if I move fast enough that covers that. But first, let me try to cover this. And if I had to use a pointer and hit the right key on here at the same time, that might be a disaster. So you just guess where I'm pointing at. And besides that, there's a thing on the slide down here in this corner, key ideas. It's kind of like key words, except for words is too weak. You got to get ideas from the words, or the words are not useful. So I want to at least give you some idea, what do we mean by leadership? What do we mean by feedback? And you can't see feedback up here unless you follow the arrows, because the definition of leadership that applies, in my thinking at least, is the ability to reconcile opportunity with competency. And the purpose of the feedback loop is to keep improving our competency when three people with different backgrounds exchange ideas about what we're doing. And supposedly then, and the idea of an opportunity came from the Atlas Challenge announcement. We immediately converted that into an opportunity to do this, to try and communicate at the end. Because the process that's going on here is we take pertinent information, knowledge, and wisdom in, and supposedly we put out useful information, knowledge, and wisdom from our work. So now it's all abstract. We don't have a real thing yet. We're just helping develop real things. And what do we mean by wisdom? Well, it's now made to be sort of a different, it's kind of an amorphous thing we're trying to capture. So there's a process you might call, in the way people talk anymore, at least about sustainability, wisdoming or wisdomability. But essentially, we're going to come out with our version of wisdom in the end, essentially because we're mainly abstract. We can give you a lot of information. We can tell you about what knowledge we use and that sort of thing. But then you'll have to, we brought up trust today as an issue, and part of the autonomous driving thing is a trust issue, and part of this process addresses trust. And I'm going to try to look at slides later. I've told you much of things. Purposes are, see, I'm thinking about something that goes into this STEM program of education, science, technology, engineering, and mathematics. And it turns out from my use of mathematics in trying to figure out what we're doing here is you need purposes that are shown up here. Because I need another equation to solve the mathematics of making this work out. I know physics. I know I got to take care of position, velocity, acceleration, those kind of things, because that's what, if you work the actuators on the vehicle, that's what's going to happen. You're going to get something about position, velocity, acceleration, and maybe you need to worry even about the rate of change of acceleration, how quickly that's changing. And Sean had this thing about time, and we're going to use the time gap idea. So now I've told you the whole talk without showing you the talk, essentially. So and I'll just talk about the key ideas. You can look at the words, although they're, first of all, you need to think about a trip to understand the way my perspective is. It's about an individual. Think of yourself as driving the car on a trip. You have an origin and a destination, and you turn Scott's thing from the other day, you turn the ignition on in the beginning and you turn the ignition off when you get to where you want to be. And, but along the way, there's all kinds of things that come up. You have to identify somehow what you've learned to do. You've learned to do all this. So you know if you want to go to the right, you turn the wheels, rotate it to the right. And if you want to go to the left, you rotate it to the left. And you put on the brake if you want to slow down, and then you push on the accelerator if you want to speed up. And you've learned to do that so well you don't have to think about it anymore. And we couldn't do what we do out on the road if people haven't learned to do this well and still have the ability to do it well. But you don't need to know all the physics and all that stuff. And my claim is that, see, what I got here? Oh, design philosophy. Anyhow, I'm telling you the design philosophy at this minute, and then we're going to get to guidance and wisdom, which I'm going to give guidance, and it's supposed to represent wisdom in how you design one of these systems. And the final thing is that our purpose is to make sure this onboard system in at least some ways can surpass human capabilities in perceptual awareness, decision-making, and the operational aspects of driving. And, well, and I would just say there is hardware done for doing some of these things. Okay. So I've talked about the pertinent information, essentially. I mentioned the STEM thing. I haven't mentioned robotics. The final vision here along the way is of all the ways people have talked about this technology getting infused and used in place of people, is something from my perspective, from this perspective of people doing trips, was somebody talking about the astronaut out with his robot doing things that he couldn't do well, like get something from the space shuttle came and he was out there putting it in. So I want you to somehow, by analogy, your ability to use analogy, to try and think of what we're doing as advocating this control system between the operator and the robot, and his robot or her robot. So, but given the background, we have slides from business planning for older drivers. We have slides on safety and mobility, essentially the AASHTO hand policy on geometric design, and then whatever guidance I can come up with from my background, which is mainly adaptive cruise control and field operational tests of that system. But now this is a broader, the keynote speaker this morning had one of Dolly's figures, and I've had that same feeling. And in fact, in our tour of the art museum, I went to look at abstract and modern art to see if somehow I could come up with as good a choice. And I think our keynote speaker did better than I would have done. But so, okay, now we're in the business planning. The thing I would emphasize here is crash avoidance. It starts out, this slide starts out with accidents, and then just goes through more or less Sergio's common sense, but he has some slides to back that up, but not the evidence that you would present if you were doing this as a methodology and explanation to others. So he's arranged these sort of arrows that change you from one block to another in a diagram. And, you know, the older people are more mobile than in the past. They're driving later on in life and driving more miles than before. And this is just in the idea of, is there a market? Or from an economist's point of view, where's the money going to come from? But he doesn't, you know, he just gives you background on that. And another area to think about is if you limit the mobility of older drivers, what are the losses? And we've heard, this is stuff that's been covered from its other perspective today, and you're very well of. You know, and I'm still in the position of you know, your view is you got one to work on, and I'm trying to design one for you to work on. But I don't have one to give you at this point in where we've gone. Now I'm going into the civil engineering world and trying to relate it to safety and mobility right away. Simple analogy. If you know, have people here used what I'd call conventional cruise control before we had adaptive cruise control? Yeah. And I don't know how many people have used adaptive cruise control. Adaptive's a little trickier because it gets into this time, velocity, position relationship that Sean talked about. So anyhow, this is Rachel's version of going through the AASHTO book on policy, which I have to tell you is, or just give you, I don't have pictures of these abstractions, but it's, you know, it's a book that's yay thick, and it's a compendium of knowledge. And it's really well organized and all that. The problem is, if you go to it, you better have a purpose, or you're going to spend a long time thumbing through pages. So what, whoa. Anyhow, what Rachel has done is gone through the book with sort of our group thing of what happens, what does safety and mobility mean? Well, the first thing that we bring up is velocity in both contexts. Accessibility is one thing, but how long it takes to get there and how you're going to get there is mobility. You know, it's accessibility, but also with this time and that kind of distance between vehicles and things like that involved. And the thing in the old cruise control is you set a speed, you looked out the window and decided what that speed ought to be, and then the vehicle would go at that speed. And most people, or many people that did that from our field tests with these kind of systems before they went beyond adaptive cruise control, was that they would get out of that mode of motion. Time's up? Okay, I'm going to have to fly. Okay, they would get out of that mode of motion by hitting the brake, which would cut you out of that mode. Okay, so now, and there's more things here that are more complicated things. I wanted to mention a project that we're talking about, and Sean's talked about it, communication between the vehicle and the highway department's box on the side of the road, essentially, and how that would then expand the Scrabble you saw in the presentation by the our first talk beginning. So anyhow, what I'm going to try to do is use this is the methodology that we're pursuing, and it's based on some work which the adaptive cruise control was before I knew of this work by Rasmussen. The title is very important: Skills, Rules, and Knowledge, Signals, Signs, and Symbols, and Other Distinctions in Human Performance Models. So what we're trying to do with this talk is simply say, take away human performance and substitute robotic controller performance. And that would be a device that we would eventually make. It could be used with driving simulators as part of gaining experience. The thing about experience is that there's an ability to generalize that only the inexperienced can have. And you sort of need to have experience to justify, verify what your wisdom is. So this is going to just run through this. This is a set of equations that I mentioned earlier, that just an example of that for cruise control, and this range minus TH, the headway time factor, and the velocity that you've already heard about, but it's set up so it equals 0, because you're not always at where you want to be, and so there's a discrepancy, which is E, and your goal is to make E equal 0, but that's the equation you need to figure out what to tell the actuator to do. So, and that's what that last equation, and you also need to know this range rate, which happens to be the preceding vehicle's velocity minus your velocity, where speed got changed into velocity number now, but you're going to measure that. So this is now a computer diagram, simplified, but something like you might use on Simulink to make a digital model of this, or in an analog computer where you had real-time integrators that were part of the system. So in this, just here's the road environment, here's the control rule calculation, here's what the conventional cruise control system does, except for this is a mode now of the operation of this overall process that says that I'm sorry, I'm pointing at the wrong thing, down here at the bottom, okay? That VC coming in here is the command that you calculated, and you're comparing it to the actual velocity. Okay, so there we've got through that, and I have another minute. This is a diagram. This is my attempt at modern art. It shows you all the things we're doing, because you have to decide when to use regular cruise control. If there's nobody on the road besides you, you use regular cruise control. If there's a car there, then you have to switch to this other mode. And this is now just an example where we won't overshoot. And this is a sort of the project chart, but it's going through and telling what all these things are about our guidance to those buildings. So we haven't gotten to this point, but we want physical just means there's hardware components, and this is the actual layout positions of things. So you have a real object that you can then do this evaluation process on. And these are sort of the correspondence between this design process and what it means to the evaluator, if they go as far as saying, criticizing the design process even. So my concluding statements are sort of progress stated in these abstract terms, and it's something about that I didn't get to, but actuators have to be robotic actuators. They're a little different than what the original vehicle had. And there's a lot of math and so forth and science and control theory that goes into that. And then there's a list of next steps here, and they're labeled 1, 2, 3, plus sign meaning and, sort of. But it just, those cover getting into new ideas and using them and getting in this idea of signs, which tells you logically which thing you ought to be working on because of the data or the inputs, sensors, and communicated information you have, to know what you ought to be doing now. And then there's a control rule for doing it, and we have to expand that to do turning, which would be another 20 minutes at least, and maybe longer. And then, whoops, sorry, I went back. Okay. So I should have said this in the beginning, but this last slide is what the pertinent information was that we started with, if you remember the diagram of the flow of this methodology. And now, I should have gotten now, this whole presentation was just an attempt at now using real time to convey ideas. It's almost like driving. You don't have any choice. You do what you do with the time available. Thanks.
Thank you. This concludes our session. I believe we're about 15 minutes behind, but I don't know if you can squeeze in one question for any of these. Okay. Any questions for any of the 4 speakers? Please let me know.
During the break.
Okay. During the break, if you have questions. All right. Thank you.